Okay, hello. So, contrary to the schedule, I'm not Ian Jackson. I'm Ian Campbell. Other Ian couldn't make it, and we're fed up of only being confused with each other half of the time. So we thought we would switch, and I'd give his talk for him. So yeah, if I appear to be reading off a script, sorry, but that's because I am. So osstest is the Zen project's automated test system. It's what we run. We run a production instance that takes every commit that's made to the mainline Zen trees and runs them through a set of tests before they get promoted to the sort of master branch. So any of the committers will only be committing to a staging branch that is then automatically propagated to master if tests succeed and there are no regressions and these sorts of things. So this is an example of the email that is sent. And you can see here that there's been a regression in the build, and that will therefore have prevented that code, the changes involved in between these two tested versions from propagating to the master branch. When there is a regression, osstest will actually bisect across it. Here's an example of the result of that. So it'll take all of the different trees that are being tested, and it'll figure out which one has caused the problem, and it'll figure out which change set within those trees caused the issue. And so here's an example of names removed, a test that broke something at some point. So the osstest focus is on sort of basic functional testing in a matrix of configurations rather than full system, for example. And so, for example, we're testing libvirt as part of that. So a complete Zen system uses quite a large number of components other than just the main zen.git hypervisor and tools, and we test those as well, and many of those have their own push gates. So obviously we have branches, so you can see on the left-hand side, these are all the branches that we test. So we test the stable branches as well as Zen unstable. We test the QEMUs as well, and we test various other things. So these, for the most part, all have push gates, although it's not necessarily assumed that the push gate will be something that you would consume. So where we're testing an upstream tree, really you'd be using the upstream master branch, and the push gate is just there to serve as metadata for how far we've got through testing upstream. But this provides us with always usable versions of each component, which means that when we come to test some new changes, we can hold all the other components steady and figure out, that helps us to figure out which one has changed and therefore broken something, and allows us to spot upcoming problems in projects that we depend on, like QEMU and libvirt, things like this. So as well as the production instance, which has been running for a number of years now, 4 or 5 years, more recently there's also been introduced a standalone mode, which is described in the README in the source tree. And this doesn't depend upon sort of all the infrastructure stuff that's in the production instance, so it doesn't depend upon the database. There's a Postgres database in the real one, and there's various host allocation and scheduling bits that don't come into play. So it's standalone mode. You just need a DHCP server and a Pixie server and a local web server that can serve up the static data that it needs, and you can then run that and you can reproduce the tests. If a test is failing and you want to reproduce it using the actual OSS test, then you can do that. It's also very useful for developing OSS test itself, and it provides a reasonably convenient way of regrooving a new box with the latest, Zen bits. So currently, osstest runs in a test network on Citrix's Cambridge offices. This is a graph showing the 13 machines that we have. So there's a dedicated pool of 13 x86 machines, and for ARM, we have these 2 Marilith boxes are an ARM server from Calcida, who've sadly gone broke since we got hold of that. So test reports and logs are posted publicly, so those emails that were on the screen earlier are sent to Zendevel, so you can subscribe to that, and if you're worried about the flood, then there's a fairly easy to filter. If you just filter for test square bracket, you'll find those pretty easily. osstest itself is open source. I think it's some variant of GPL3, AGPL or something, and is published on ZenBits alongside the Zen source code, osstest.git. And each of the emails that get sent out has at the bottom the URL of the exact version that was used to test, to run that particular test. And as always, contributions to this are always very welcome. In fact, mainly what I'm doing is soliciting such contributions. Hello. Yeah, fine, yeah.
So the tested operating system, you basically, to simulate the real environment, you need to have a variety of different applications that would execute on the operating system, and then you would see how balanced the response is.
Right, so osstest is mainly focused on functional testing. So the test cases are things like starting a VM, stopping a VM, live migrating a VM, those kinds of things, as opposed to full system testing, which I think is what you're getting at, where you run actual workloads. So there is some ongoing work.
But it's still about functional, sorry for the interruption.
Sure.
Because if you run, let's say, multiple different applications that do different functions, it may lead to bugs, to revealing bugs in your underlying system.
Sure, yeah.
So that part is interesting to me, how actually you do that.
So effectively today, we're quite resource constrained in what, so we have a very small pool of machines, and that has, I was going to get onto this later, but that has sort of hampered the amount of extra stuff we can test. That's going to change. I think I can go on to that as we go.
One thing that's worth adding to that, obviously Ian's talking today about osstest, but there are a number of other test activities that are going on in the community. So I know Intel do a lot of testing of their various processes, various virtualization modes, and I think that includes the kind of thing gets test we're talking about. I'm part of the Zen server product group, and we do an awful lot of testing, again, making sure that when we run applications inside Get, things work very well. So within the broader Zen community, that stuff is taking place. What I'd love to see with osstest in the future is that we kind of centralize some of that.
Yeah. So related, although not exactly identical, Dario is one of the developers on our team, is working on extending osstest to be able to run benchmarks and to run different workloads and gather results and build up a database of sort of performance reasons. He's a kind of a scheduler guy, so that's why he's interested in that. And that will then, I think, spread out into more workload testing and more of that kind of thing. Does that answer the question?
Yeah.
Great. So these machines are all inside Citrix. They're on a VLAN in the data center in Citrix's Cambridge office, which means it's not really possible for other members of the Zen community to gain access to the test environment and to help out with administering the production interface, production instance. Sorry. So the Zen Project Advisory Board have agreed, and Lars mentioned this yesterday in his opening stuff, that there's going to be a new facility for automated testing. And there's been a test working group set up. And I'm glad to see Don here because he can answer any questions about that aspect side of things because I'm not involved there. And they've been working out the details. And I believe they've now selected Earthlink in Massachusetts to host for co-location. And they're planning an initial deployment of 24 x86 hosts, I presume, which will practically double our capacity. There, as James mentioned, there are other test frameworks available, and there's been some talk about whether we should stick with osstest or whether we should be thinking about switching to something else. So for now, the test working group have agreed that we're going to move the existing thing into the new facility, but the new facility has been designed to give us some flexibility about using other things in the future, maybe switching to ZenRT for some, and then we can evaluate and plan transitions and have some capacity for that sort of thing. So originally, Ian Jackson was the main author of osstest. I think he started in 2009, and he still leads the maintenance. But in the last couple of years, there's been contributions from a bunch of new people, and those names and numbers are start dates of people contributing to it. And the graph shows a proportion of the osstest code base by the month it was written. So I think what it's intended to show is that there's been a lot of change in recent times. I think the slides will be online on SlideShare later. And apparently this big spike is in 2012 is some code reorganization that made it look like we've moved around. But also we've sort of been trying to answer more inquiries and get people up and running, especially with standalone mode, and we've been using the documentation days to improve the docs. So if you want to try it in standalone mode, then the README now exists and has useful information in it, as opposed to previously where you had to go and stand by Ian's desk until he told you how it worked. and it's been much simplified. So it used to be with standalone mode, you had to run all these little scripts manually, and there's now a helper wrapper to sort of guide you through the process, and you can sort of tell it the thing you actually want to do rather than the 10 steps. And as you can see, we're expanding the contributor base, and we're hoping that with the move to the Colo and the more accessible, that we'll be able to get more contributions that way.
I just have a little background question. So how many repos are you testing against? And I know you have lots of branches and stuff too, right?
So each branch here on the left basically represents a repo or a branch within a repo. Right. So there's, in fact, actually, I think the next slide was going to be, yeah, so here we are. So the blue line is the number of repos we're currently testing against. So it's sort of up to 14 at the minute. And the red line is the number of test jobs in an individual branch test. So there's 60-odd jobs testing Xen Unstable at the minute. And the increase here is, as we've started recently, we've been adding testing of third-party components that we rely on. So libvirt and QEMU upstream, more Linux upstream branches, things like that. So for code that comes from the Xen project, yeah, we commit to a staging branch, and then a cron job, basically osstest as a cron job, runs and sees if there's anything new to test in each branch, and then pushes that.
If that doesn't work out,
then it
doesn't get merged.
It doesn't get pushed. It gets pushed to master. So the only OSS test pushes to master, basically. So if it doesn't pass, it doesn't push, and then you'd expect that more changes would arrive in staging that would eventually fix it, at which point it'll all get flushed through. Does that make sense? And then for some of these things, like the Linux branch is testing Linus's master branch upstream, and there's no sort of staging master arrangement there, but there is an output from that test. So if you want sort of the latest Linus that's been tested, you can go and find a thing. But the purpose there is more for tracking that upstream isn't regressing rather than providing a stable output. Does that make sense?
What would be, so if a test was to fail because the Linux kernel branch was broken,
yeah.
There's no gatekeeping change, but that
yeah.
requires somebody, a human intervention, to then go see what's broken.
Yeah, so there's an email that says failed or regressed or things of that nature that you would then go and investigate. Linux is kind of an independent branch that's tested independently, but if you consider, for example, Xen and QEMU, which kind of move forward in lockstep, so then we have the Xen Unstable branch, which tests the latest Xen staging branch against the most recently successfully tested QEMU, and then we have vice versa. The QEMU test will test the most recent QEMU against the most recently successfully tested Xen, so that you've only changed one of the branches at a time, so that then the test that is failing gives you some clue as to who broke.
Some changes that need both to advance at the same time.
So because QEMU is independent, we try and avoid those things. And so with the old QEMU, which did indeed come in lockstep, that just happens naturally because of our development process for updating the old QEMU does involve checking something into zen.git, so it will lockstep it in that way. Does that make sense? So yeah, new contributors have been expanding the ranges of tests, so you can see all the lines are going up and to the right as we add more things to test. We've got ARM 32-bit support, and we're kind of ready to test 64-bit ARM support when we have appropriate hardware, which I guess will be through this year. I think actually we've talked about most of this ad hoc in the questions. So yeah, we now test QEMU and CBIOS, which is the x86 BIOS that we use in HVM guests, as another branch that we added recently as making sure that doesn't regress upstream. Type test. We test all the Xen stable branches. We test Linux Next, which is kind of the Linux upstream ultra development branch where all the different maintainers things get auto merged together. And Linus's master branch as it goes through the RCs and things like this. We also have branches testing the Linux stable long-term one, so that's 3.4. 3.10 has just been announced. I think there was one in the middle as well. And recently, so rump kernels is intended to replace subdomains. So one of the first things that was done there was to add some testing for that. That's an external project to do a sort of a unikernel NetBSD type thing, which we're hoping to use. New tests include Debian HVM guests. Previously, we were testing Rail HVM and Debian PV only. Somebody has added OVMF. So someone was asking during one of the talks today whether UEFI worked in a guest, and we now as of a few months ago, actually test that, at least boot test such guests. And we also have tests for FreeBSD running as a guest. In the last little while, as we've been switching from Zendy to XL, the focus of the testing has been switching, to kind of follow that move. So tests that were previously Zendy have been moving over to XL. And that's kind of partly why sometimes the lines go up as well as down. Plus, there's been some obsolete duplicated tests because we've been so constrained with the hardware. We've had to be quite brutal about pruning things that aren't strictly testing anything that some other test isn't testing. Which is why, again, things wobble up and down rather than constantly increasing. The new test working group provided Colo really ought to help with that and give us a bit more breathing room. Although, everything expands to fill a vacuum, so I don't know how long 26 machines will go. And as I mentioned earlier, people are extending osstests to do performance measurement, and hopefully, once we got the gathered data portion of that down, we can then start looking into automatically detecting regressions in performance, which is an interesting statistical problem, I think, for slowly degrading things rather than big leaps. So that's basically it. osstest is a small but growing community. It's getting a lot easier to work on with time. We're kind of in a model where if someone has a problem, we try and write down the answer in the docs as well as just answering it. And we're hoping that moving to better infrastructure will allow us to improve the code and improve the community even further. And here are some URLs of some interesting bits. I think if you're looking for standalone mode, this README is the best place to start. There's some example output. The logs don't get kept forever because they're enormous, so they kind of get garbage collected after a certain amount of time. And a bunch of contact addresses where I see that Ian has stitched me up and put my name on the list. So there we are, source repository at the top. Any other questions?
Do you use any automated testing tools and approaches to generate test cases so that you can achieve better test coverage or speed up?
Not right now, no. Test cases are written by developer hand. So osstest is primarily written in Perl, although really all it cares about is having an executable that can run for each step of the test. So if someone wanted to implement it in some other language, there's not really anything stopping them, but it has a, like with all these things, it has a library of helpful functionality, like run this on this host and start this guest type stuff that you would need to get from somewhere. But I mean, if someone wanted to integrate Python code into osstest and provide a similar library of helpful functions for Python, then why not?
How many tests do you already have? I know that you said, but
so this is the list of jobs. So each branch will have some subset of these jobs running on it. Most of them, for example, would be on Xen Unstable, but if we were testing QEMU, we would maybe not bother testing some of the non-QEMU using test jobs. The vague pattern to these, I mean, build jobs are pretty obvious, I think, but then it's test, Xen architecture, DOM0 architecture, and then some string sort of describing the general parameters.
test total is, each test for something, so there would be probably thousands.
Yeah, so a typical one of these type things would install up a host, install a guest of some type on that host with some, SP3 or SP3 with single CPU. It would, I think, the sort of the standard guest test flight is then start it, stop it, reboot it a few times, migrate it a few times. That's about it, I think. Save, restore a bunch of times, and then so some of these will be cross-host migrations. Mostly it's local host migration just for test purposes.
And oracles in this case would be.
What? Sorry.
Each test has oracles. Oracles. When you have correct outcome.
Yeah. So we test that you can still shush to the guest and that you can still ping it and all this sort of thing between each migration or after each start and shutdown. And if you've done a shutdown, we check that it has been shut down. And so those are the sorts of things that are in the library of helper functions is, shut down this guest and check that it really has gone and things like that. Hello.
Is it relatively easy to set this up just to test it to one of the jobs for one of the branches locally?
Relative to what? Yeah. Yes, it is. Yeah. So it has standalone mode where you basically, if you have a Pixie server and a DHCP server. The basic things you need is write access to some subtree of the Pixie server, read access to the DHCP server's leases file, which can be either over a network socket or just a local file, and a web server with some web space, and you need to know the URL and the path that corresponds, and then basically you're kind of good to go. So I mean, it does everything from scratch every time, so if you want to use it in standalone mode to run a test, you first need to run a build job to have a thing that's been built. I mean, you can kind of inject things through the side as well. Yeah, so the README primarily focuses on setting up standalone mode, and it's definitely been getting easier, and more people have used it. So, I mean, Ian essentially held my hand through the process a couple of years ago, and since then, the docs have been improving, and Wei and Roger and Anthony have had less trouble than I did, and I know there are some guys at Intel now trying to use it. I think they're actually trying to set up a production, a proper production instance rather than a standalone instance, but they seem to be getting there without too much thing. So yeah, I mean, if you try it and it doesn't work, please do ask on Zendervale, and we'll figure out why our docs are confusing, probably. Yes?
The farm is all different machines, is that, or is it for
They tend to, they are pairs of like machines. So this equiv property sort of shows you which machines are the same. So yeah, it's good to have pairs for migration purposes, but also just for redundancy if things go wrong. Some of these machines are quite old and go wrong. A fairly large number of our test failures are actually because the machine forgot which driver it's supposed to boot from because its CMOS battery is running out and things like that. So. Any other questions? Comments? Anything you want to say about the test working group, Don? Or is it kind of covered it all, I guess?
Pretty much covered it all, though. I will say, part of it is right now the test check-in branches. And as a developer, it would be nice to somehow be able to test my patch before posting it and it gets accepted.
Sure. Yeah. So you can. I mean, in standalone mode, you can point it at your own Git repo of whichever bit. Yeah.
I really like to test on a wide range of machines.
Oh, I see. To do it that way. Yeah. So I think that's one of the things that the hope is. Yeah.
We've got to first get it working, and then look at what would make sense in the future, and what would be a good feature that would be beneficial.
Yeah.
Hopefully we're not going to max it out from day one.
I mean, you want some service where you send a website a patch, and it'll basically tell you it ran through the test.
And said, well, that's a good patch, or these hundreds of tests broke. And
Yeah.
That requires some serious infrastructure.
Don't even think of committing that fast.
Yeah. So I think, as with most things, the main thing that it needs is developer power writing tests. There's sort of no magic stick to a lot of it. It's if you care about a feature, implement a test case. Well, not even a case. It'd probably be a step added to one of the existing tests, or things like that. Which is not. I mean, even if you don't know Perl, it's still really it's just a case of do X, do Y, do Z in a line with semicolons between them. Yeah.
It's all in Perl.
It is, although it's. I mean, as I was saying, its main functional unit is really a process and a script. So it doesn't care what the script does and what language it's written in. It just happens that all of the existing stuff is written in Perl, and there's a library of useful Perl functions. But yeah, I think if someone wanted to make a Python library, or let's draw the line at Haskell, but
So it can actually do things like bring up a Linux VM,
yeah.
and you can interact with that VM if needed.
Yeah. So there are functions for run a command on the host, run a command on this guest, do thing X to this guest, all that sort of stuff is included.
So will these machines move to the co-location?
I don't believe so. No.
I don't believe we're moving any of the machines.
Okay, so the co-location will have new machines.
Yeah, but I presume a variety of new machines rather than 26 identical.
We're trying to get a variety where the current blocking point turns out that finding AMD server boxes with rack mounted is hard.
Okay, maybe I can help you with
Yeah. So as I understand it, the rule is that it has to be production hardware rather than development platforms or things like that.
Well, I'm not sure. We want want it to run while, I mean, part of the problem, my understanding of this box is it, or this setup, is that some of these machines have been getting old
Yeah.
and they're exhibiting issues which are not Zen or Linux.
As I said, the most common failure is failure to boot past the BIOS, you know, to even get to Zen. I mean, quite often just when running native Linux, because obviously the builds just run native Linux. They don't run under Zen at all. And yeah.
We want we want hardware which we expect to run for years, not months.
Yeah. And I mean, you guys are soliciting donations and things as well as providing budget. So.
Potentially, I mean, right now we have only bought one rack in the data center, or we're buying one rack in the data center.
Right.
And it looks pretty full. So we may only be able to do, like 5 or so additional servers. But the theory is that assuming working, things look good and the advisory board will fund it, I expect that to expand to more more machines.
Yeah.
Because while there's a cost to buying the machines up front, this is a big cost to start it. Expanding it is not.
It's more incremental, yeah. So yeah, I guess those are the two big things, is expanding the base of hardware and expanding the set of tests, which if, community members can help with either of those, then I think everyone would be grateful.
I think there's actually a mailing list for
Is there?
the work group.
Yeah, is that a public list?
I think so. Well, you may not be able to post to it. You can definitely read it, the archive.
Okay. Yeah, I don't know where you would find that. I guess Google will tell you where to find the Zen test working groups mailing list if you want it. Okay, any other questions? I think we're about out of time, so you're only eating into your own break. So thank you.